The first thing we need to do is solve this inequality. And then we'll figure out how many integers are less than 5. Well, the way you solve this inequality is you need to find the critical numbers, and those words do not mean anything for you for the Gmat. But what you do is you take these factors. It's nice they went on and factored them for you. And you set them equal to 0. So x plus 2 is 0. X plus 3 equals 0, x minus 2 equals 0. So that means x equals negative 2, x equals negative 3, and x equals 2. So these values are actually the value of x that makes it 0. So we're trying to figure out what values of x make this thing positive, greater than or equal to 0. So what I would do is put your critical numbers on your number line. There's negative 3, negative 2, I'll go ahead and put negative 1, 0, 1, 2, and that mentions this 5. We'll go ahead and put that on here. 3, 4, 5. So I'm going to mark with an X our critical numbers. So negative 3 is a critical number, negative 2 is a critical number, and 2 is a critical number. So if you look, you have broken your number line into 4 pieces. You got a piece here, here, here. So what I want to do is test each of these intervals. I want to see if these pieces, if they give me a positive number or a negative number. So let's look at this first piece, this one. And let's pull an integer from that region. So negative 4 would be in that region. So take a negative 4 and erase that. Take a negative 4 and substitute it back into your inequality. And I do not care about the value. What I care about is it a positive or negative number. So let's take negative 4. Negative 4 plus 2 is a positive or negative. It's a negative. Now you got x plus 3. Negative 4 plus 3, that also gives you a negative number. And in the denominator, you got negative 4 minus 2 is a negative 6. That's negatives. What would be 3 negatives? That would be negative. Now let's check the region or the area in between a negative 3 and a negative 2. So I'm going to use a negative 2.5. And I'm going to plug it back into this inequality once again. So negative 2.5 plus 2 is negative. Negative 2.5 plus 3 is positive. Negative 2.5 minus 2 is negative. That's a negative times a positive in the top, which is negative, divided by a negative, that's going to be positive. So this interval is going to be positive. Now we've got this region between negative 2 and 2. Let's choose 0. If I plug 0 back into my inequality, I get 0 plus 2 is positive. 0 plus 3 is positive. 0 minus 2 is negative. What's a positive, and negative? Well, that would be a negative. And let's choose this upper region, the one that's greater than 2. Let's choose 3. 3 plus 2 is positive. 3 plus 3 is positive. 3 minus 2 is positive. It's going to give you positive. So let's first look to see, we want the integers that are greater than or equal to 0, which means positive. So where is it positive? It's positive up here. Let me use a different color. So this is positive. And where else is it positive? It's positive here. Those are the intervals where it's positive. And we want to figure out how many integers are there less than 5 that satisfy this inequality. So look at the yellow regions. So there's an integer that worked. There's an integer. You don't count 2 because if you look at 2, look at your denominator. 2 minus 2 is 0. You can't have 0 on the bottom, so you can't count that. Of course, this region in between negative 2 and 2 is negative. So less than 5. So then you've got this, look at this region, this yellow region. You've got that one and that one. It's okay if the numerator is 0. So we had 4 integers that satisfied this inequality that were less than 5.